LeetPorn 16, threesome closest in JavaScript. Given an integer array nums and an integer target, find the three integer in nums whose sum is closest to target. Return that sum. Each input has exactly one solution. So that means there must be at least three numbers in there, and we want the three numbers whose sum is closest to target. Given a target of 1 and this input, the output is 2, because the sum of the three numbers closest that will add up to the sum of three numbers that are closest to 1 is going to be -1 plus 2 plus 1. And that is equal to 2. And that's the sum they want. So they need to know two things. We need to know the closest one, and then we need to know the closest sum, and then we need to know what the value of that sum is. The closest could be the target, in which case we return early. It could be above or below it. So we have to use absolute value to check that. First thing we do is we sort the array. And the input array sorted, and there's our target 1, looks like this. We're going to have an outer loop that starts here, an inner loop where the j pointer starts here, and the k pointer starts at the end. So the inner loop is going to loop up until 2 before the end. The outer loop is going to loop 2 before the end. The inner loop is going to start at the outer loop and then loop 1 before the end. And the inner loop's other pointer, the inner loop's second pointer, the k pointer, is going to loop from the end until it meets the inner loop. I'm going to loop all the way back to whatever the inner loop's j pointer is. And those two, every time that j and k pointer overlap, then we go back to the outer loop until we're done. And then we return our best sum. So we start with a sorted array. We're going to have to keep track of the difference, and we start out by having the max safe integer. And that's a number that is larger than 10 to the power of 4 plus 1,000. So it's larger than that. So the first time we get an iteration on this, it'll be our next best diff. And that diff will be used to check to see if the one we get after that subsequently is smaller. Because if we get a smaller difference, then we're going to use that sum. Okay, so we're going to keep going until we're done or until we hit target. So the best diff is number.maxSafeInteger to start. We start our I loop at 0, and then we're going to check to make sure we don't get any duplicates in here with that previous variable. We're going to loop up until 2 before the end of the array, and then we're going to start our inner loop where j starts right after I plus 1. K is the last element in the array. And as long as j and k haven't overlapped, as long as j is less than k, we're going to add the three numbers together and see if we have a winner. And if the test sum is equal to target, then we break and we return that best. Now if it's not, then we have to see if the test sum is below the target or above the target. Now if the test sum is below the target, let's say we add -4, -1 is our I pointer, -4, j pointer is -1, k pointer is 2. If those three numbers are less than, let's see, -4 plus -1 plus 2 is -5 plus 2 is -3. That would be the sum that would be closest to target. And the difference from target is 1 minus -3. 1 minus -3 is 4. 1 minus -3 is 4. So we have -5 plus 2 is -3. Sorry, -5 plus 2 is -3. That's correct. And the difference between 1 and -3 is 4. So now we have to check to see if that difference is better than our best diff. And of course it is, because we started out with a very large number. And then the best sum that we have is this test sum. We said that was -3 right here. That's the best one that we have so far. We'll get rid of that for now. Okay, so now we have to see if we're below the target, and we are, because -3 is less than 1. So now we have to increment the j. So now we're going to go -4. We're going to increment j. We're going to go into our loop again. We're going to add these three numbers together. We have -4, 1, and 2. That's -1. Okay? -1. We go down and we check to see if 1 minus... We go to see if the test sum, if -1 is target, it's not. Now we see the absolute value of 1 minus -1. That is 2. Is that less than 4? Yes, it is. Our last best if was 4, so that's less than 4. So now the best one we have is going to be, the test sum is going to be -1. That's the best one we have so far. The best diff is going to be 2, so we use that for our next check. And now let's see, is the test sum under the target? -1 is less than target, so now we're going to increment j. So we have -4, 1, and 2. Now we have -3 plus 2 is still -1. We already did that loop, sorry. -4 plus 1 plus 2 is -3. -4 plus 1 is -3 plus 2 is -1. We already did that one. Okay, so now we're on the next one. So now we incremented j, and now j is pointing to k. So now we go to the next one. We go to -1. On our I loop, we increment I because we're done with this loop, and then we're done with the next. We're out of this loop, and then we go to the next thing in our control structure above, that I++. And we're going to increment that, and then we're going to go to the next one. We're going to choose n is index I is going to be 1, so n is -1. And in our k loop, we're going to have 1 and 2. So that's going to be equal to 2. Okay, so now we're going to have 2 in there for our test sum. And the test diff is the target minus the test sum. The target is 1, and the test sum is 2. 1 minus 2 is -1. So is the test diff -1 less than our best diff? Well, it's actually going to be 1 because we use absolute value. Yes, it is. So then our best is the test sum, which was 2, and the best diff is equal to the test diff. Okay. So now we've got 1, 1, and 2. Now, let's see, if it's under the target, no, it's above the target. So we decrement k. Now k is here. So when we have I is 1, j is 2, and k is 2. We go back up to our check here. Is j less than k? No, j is equal to k. They're both 2 at this point. So then we would terminate that loop. And then we would go back up to the outer loop. Is I less than last minus 1? No, I is right here. I is less than last minus 1. Yeah, I is 1. So now we're going to increment. We incremented I in the last one, so now I is last minus 1. So I is going to be pointing to here. So that I got incremented after that. So now we're done. We're essentially done with this loop, and we can return the best. And the best we got so far, the test sum was 2. That was assigned to the best, which is 2. And so we're done with this loop. And that's how this algorithm works. And you can see that it works and it runs. I've gotten really good results out of this. Varying results. Sometimes it gives you better results than others, but this is not bad. So this is probably one of the better ones. And I just made some minor tweaks on this. It's all just renaming variables and stuff to make it clearer for the example for you guys. So there's how to use the sliding window on 3-sum closest. Thanks for watching.